In this video, we'll see how to do retrieval augmented generation on audio files using LangChain and Python. So here we can see the end result. LangChain transcribes our 3 audio files, and then we enter this question here: what is retrieval augmented generation? We see the response that the language model generates, and then we see the source files that were passed into the language model as context when it was generating that response. So for each source, we see the section of the transcript that's relevant to the question, and then we see the original audio file from which this transcript was pulled. You can find all the code for this tutorial in the project repository that's linked in the description, and you can follow along on our blog if you want to easily copy and paste the code as we go. Retrieval Augmented Generation, or RAG, is a way to enhance the transparency and relevance of LLM responses. We do this by supplying the LLM with documents that are relevant to our query, so that it has them when it's generating a response. We'll be combining several technologies to do this. First, we'll use Assembly AI to transcribe the audio files into text. We need to do this because LLMs can only process textual data. Next, we'll use Hugging Face to embed these documents. These embeddings are numerical vector representations of the documents that capture their meaning. If you need a refresher, check out our video on vector embeddings. Next, we'll use the vector database Chroma to store these embeddings. This vector database will make it easy to perform a similarity search so that we can extract documents that are relevant to our query. Finally, we'll pass in the retrieved documents as additional context when we query OpenAI's GPT model. And we'll use LangChain to tie all these pieces together. If you need a refresher on LangChain, you can check out our dedicated video. Alright, let's get started. Create a directory for your project and navigate into it. We're going to create a virtual environment using venv. Next, to activate the virtual environment, if you're on Mac, you can use this command, and if you're on Windows, you can use this command. Now we need to install the libraries we're going to need for this tutorial. So we're going to use Assembly AI, LangChain, OpenAI, Python.env, which will allow us to manage our environment variables, ChromaDB, and sentence transformers from Hugging Face. Now we're going to set up our environment variables for the project. So create a file called .env, and then paste in your Assembly AI key and your OpenAI key. So you'll just paste them here after the equal signs. We want to make sure to not check this file into source control because it contains our API keys. So create a .ignore file or .getignore file. And you can paste in the .env and the virtual environment. And this will just prevent you from accidentally uploading these to GitHub or something like that. Now we're ready to write our main application code. So create a file called main.py. And first we're going to start with some imports. First we're importing load.env. So this will allow us to load our environment variables from the .env file. From LangChain, we're importing the retrieval QA chain. So this is the actual LangChain that will allow us to do question and answering with retrieval. We're importing the chat OpenAI model. So this will allow us to communicate with the GPT model. We're importing the Assembly AI audio transcript loader. So this is what will allow us to load audio files in as text. And it uses Assembly AI under the hood, so we don't have to worry about the transcription. We'll import Hugging Face embeddings, which will allow us to generate the embeddings from our documents. And we'll import the recursive character text splitter, so this will allow us to split our documents into smaller chunks so that we can only retrieve relevant parts of the document when we're doing our generation. And finally, we'll import Chroma, which will be the vector database that we're using. And finally here we call load.env, so this is what actually loads the environment variables from our env file. Next, we'll specify the audio files that we're going to use for the retrieval augmented generation. So we'll just specify these in the list. And these are URLs to remote audio files. And all these audio files are pulled from LangChain's webinar series on YouTube. These files can be either local files or remote files, but if they're remote, you need to make sure that they're publicly accessible so that Assembly AI's API can access them. Next, we'll use the Assembly AI document loader in order to load these audio files in as text, but this loader can only handle one audio file at a time currently. So we'll write a short function here to just loop through each file and append the results to a list. And depending on the length of these audio files, they might take a little while to transcribe. So usually they'll take around 15 to 25% of the length of the audio file. And so we have a print statement here that will just update us every time a new file is transcribed, so we can just see the progress. And finally, we just call this function on our list of URLs to create our docs. So during retrieval, we'll search our vector database for relevant documents and then pass them in as additional context. And it's going to pass in the entire document that's deemed to be relevant to the question. So what we're going to do now is split up our transcripts so that we can just select out relevant chunks of the text. Because if we have a transcript of a 1-hour audio file, it's unlikely that that entire hour is going to be relevant to our question. So we define a recursive character text splitter, and we define a chunk size and a chunk overlap. So the chunk size just determines how big each chunk of the transcript is, and then the chunk overlap of 0 just means that these are non-overlapping pieces. Next, we actually do the splitting by calling the split documents method of the text splitter. So we pass in our documents, and we're going to get back the texts, which is just the split up documents. Next, for each of these texts, we set its metadata to be the audio URL of the file from which it originates. So the reason for this is that the Assembly AI transcript loader returns a ton of metadata about the transcript, so whether or not speaker diarization was enabled or any of the other possible features of the API. And so what this does is it just isolates the information that's necessary for this tutorial. Now it's time to embed our texts. So we create a function here called makeEmbedder that returns a Hugging Face embeddings object. We specify the model that we want to use, we specify the device on which the model should operate, and we specify the encoding keyword argument. So this is just saying that we don't want to normalize these embeddings. Now we use this function to create an embedder, and then we create our Chroma database by feeding in our texts along with this embedder to the Chroma from documents method. So this will build a Chroma database using our text that we passed in, and the embeddings will be created by this embedder object that we just created. Now it's time to actually create the question and answer chain that pulls all of these pieces together, and that's what we actually use when we're querying our model. So we create this make QA chain function, and what this does is it returns a retrieval QA chain, and we just pass in the model that we want to use. We pass in the retriever, which is just the database, so this is what retrieves the actual documents. And we specify the search type here, which is maximal marginal relevance, MMR. And then we specify that we want to fetch the 3 most relevant documents. And then finally, we just specify here that we want to return the source documents when we query this chain. And finally, it's time to actually write the main loop of our code. So we create an instance of the QA chain, and then we create a while loop. First, we get an input from the user. So this will just be the question that they want to ask the QA chain. And we give them the option to break out of the loop if they want to end the program. Next, all we have to do is simply pass this question into our QA chain, and then we can print the results. So we'll print out the question to the terminal, and then we'll also print the response of the QA chain. And finally, we'll print out each retrieved text that was passed in during the Retrieval Augmented Generation. So we simply enumerate over each of the source documents from the result, and we print out the audio URL, so this is the audio file from which this text originates, and then we print out the content. So this is the actual contents of the partial part of the transcript that was passed in during the Retrieval Augmented Generation. So this is just the component of a transcript that was determined to be relevant to the query. And now we can actually run the application. So just go into the terminal and making sure that your virtual environment is activated and you're in the right directory. Just type in python main.py, and you might have to use Python 3 depending on your system. If you receive a Hugging Face error that the current process just forked, then you can go to your .m file and paste in tokenizer's parallelism equals false, and that should take care of it. And here we see the first file is being transcribed by Assembly AI. And now we can see the second audio file is being transcribed. And now the last audio file is being transcribed. And now that the audio files have been transcribed, we have embedded them and then put them in the vector database. And now we're ready to query our QA chain. And we can see here that our answer was printed out. So we have the question, what is Retrieval Augmented Generation, RAG? And we have the answer here: Retrieval Augmented Generation, RAG, is a method that combines information retrieval and language generation techniques. So you can see there's the rest of the answer, and we can see our retrieved documents are printed here. So we have the first source here, and we have the file path. So this tells us which document that this text came out of, and then we have the source text. So this is the actual transcript of this file, and the part of the transcript that was determined to be relevant to this question. And here we have two more sources with the text and their source files as well, because we asked for 3 sources to be returned. And that's it. That's how to perform Retrieval Augmented Generation on audio files in Python. If you have any questions, leave them in the comments below. Otherwise, I'll see you in the next video.